what if you could have a robot doing all your chores for, about the price of a used car? I know, right? Sounds kind of like sci-fi.
Yeah.
But it's not. We're talking about a robot today.
Yeah.
And trust me, you're going to want to stick around for this. And hey, while you're at it, hit that subscribe button to support the channel. You won't regret it.
So you're intrigued, huh?
Absolutely.
Yeah.
$1,000 for a robot that can, potentially fold my laundry. I'm all ears.
That's the magic of a robot. It's designed to be this incredibly affordable open source platform for research and development in embodied AI.
Okay.
Basically, it's breaking down all the barriers that have kept advanced robotics out of reach for, most people.
Okay, I'm following you. But why has it been so expensive to build these kinds of robots in the past? What's AhaRobot doing differently?
Well, think about the robots you usually see in, labs or factories. They're often huge, specialized machines with, super precise and super expensive components.
Right.
AhaRobot, flips the script. It's built almost entirely from off-the-shelf parts, kind of like a really advanced DIY project.
So it's like building a high-end gaming PC.
Right.
But instead of a computer, you get a robot.
You got it. And that's just part of the genius. They've also addressed a major limitation of a lot of robots' workspace.
Okay.
Think about it. Most robots are kind of stuck in one spot, right?
Yeah.
But AhaRobot is designed for whole-body mobility. It can move around, reach different heights, even get down to the floor.
Right.
Which is something a lot of robots just can't do.
Yeah, that makes sense. I mean, if you want a robot to help around the house, you can't just stand there like a statue. It needs to be able to navigate and reach things.
Exactly. And that's where AhaRobot's unique design comes in. Imagine a robot with 2 arms, but instead of traditional shoulder joints, it has this clever lifting mechanism that moves the entire upper body up and down.
Wait, so the whole upper body moves, like it can actually stand taller?
Yep. They use a belt-driven slide system, which is much faster and more efficient than other lifting methods. This lets our robot reach a wider range of heights, and it also prevents those frustrating failures that happen when a robot drops something and needs a human to intervene.
I see. So it's designed for more autonomy. It's less reliant on humans to fix its mistakes. That's a big deal if you want a robot to actually be helpful in a real-world setting.
Right, and that practicality extends to its arms as well. They're configured in this horizontal, Scara-like design.
Okay.
You might have seen this in industrial robots, think like car assembly line.
Oh, yeah, those big robotic arms that weld and assemble things.
Exactly. But AhaRobot miniaturizes this concept. The horizontal configuration has a few advantages. It reduces the impact of gravity, which means you can use smaller, less expensive motors. It also makes the control algorithms simpler. And from a design perspective, it's just more compact and efficient.
So they're taking inspiration from industrial robots, but adapting it for a home environment, making it more affordable and easier to control in the process?
Yeah.
That's clever.
Right. But even with those lower-cost motors, they needed a way to achieve high precision. And this is where it gets really interesting. They use a dual motor system for each joint.
Dual motor. Okay, you've piqued my curiosity. Why 2 motors?
Well, think about how our own bodies work. We use opposing sets of muscles to achieve fine control and stability. Our robot mimics that with 2 motors working in tandem. It's a bit technical, but this system essentially eliminates backlash, which is that annoying play or lag you can sometimes feel in gears.
So it's like having 2 hands on a steering wheel instead of 1.
Yeah.
You get more stability and precision.
Exactly. And another benefit is modularity. If one motor fails, you can easily replace it without having to rebuild the whole joint. It's designed for easy repair and maintenance, which is another factor that keeps the costs down.
I'm really starting to see how all these design choices work together to make AhaRobot both capable and affordable. What about movement? How does it actually get around?
It's got a pretty standard differential drive base, 2 independently powered wheels, and a caster wheel for stability. This allows for some pretty tight turns and maneuvering, which is essential for navigating a cluttered home environment.
So it can weave around furniture and squeeze into tight spaces.
Yep. And the base is relatively compact, so it's less likely to bump into things. They really thought about the practicalities of operating in a home environment.
Okay, so we've got a robot that can move, reach, lift, and manipulate objects.
Yeah.
What about the brains of the operation?
Right.
What kind of sensing and computing power are we talking about?
A robot is surprisingly sophisticated when it comes to sensing and computation. It actually has 3 cameras.
3. Wow, that's more than I expected.
Right. There's one on the head that provides a panoramic view, and then 2 wrist-mounted cameras that are used for more detailed manipulation tasks.
Okay.
So it can get a sense of the overall environment and then zoom in on what it needs to grab or interact with.
It's like having eyes everywhere. It can really see what it's doing.
And to make sure it knows where it is in space, it also uses high-precision encoders in each joint and in the base motors.
Proprioception. It's like the robot's internal GPS, letting it know where all its body parts are.
Exactly. And for the computing side, they've kept things flexible. It can run complex AI models using a mini ITX computer, but for less demanding tasks, you can use cheaper onboard chips.
So it's adaptable to different levels of complexity. You can scale up the computing power as needed.
Precisely. And that brings us to one of the most innovative aspects of AhaRobot, and that's the way you control it. They've developed this incredibly clever teleoperation system called RoboPilot.
Teleoperation, you mean like remotely controlling the robot?
Exactly. But here's the kicker. RoboPilot is unlike any teleoperation system I've seen before.
Okay, now you've really got my attention. Tell me more.
Traditional teleoperation systems often involve bulky VR headsets or expensive motion capture suits, but RoboPilot throws all that out the window.
So how does it work? You just think really hard and the robot moves?
It's actually way more intuitive than that. Imagine this, you're holding 2 handles, kind of like handlebars, each studded with these special markers. These markers allow the system to track your hand movements with incredible precision.
Hold on, I'm picturing this moving my hands around, and the robot's arms are mimicking my motions.
Exactly. It's like you're reaching out with the robot's own hands. And to control things like base movement, gripper functions, and the lifting slider, you've got 4 foot pedals.
Foot pedals, like in a car.
Yep. It's all designed to be really intuitive and natural. They even have different modes for walking and operation, so you can switch between controlling the base and the arms seamlessly.
So it's like you're piloting this robot, using your whole body to control its movements. That's so cool. But is this setup super expensive?
Get this, each workstation costs less than $50 to build. That's cheaper than a lot of video game controllers.
$50? That's insane. But wait, can something that simple really control a complex robot with that level of precision?
It absolutely can. Remember those markers on the handles?
Yeah.
They're the key. They use this 26-faced marker system to capture the full 6 degrees of freedom of your hand movements.
Okay, you lost me a bit with the technical jargon. 6 degrees of freedom. What does that even mean?
It basically means it can track your hand's position and orientation in 3D space with incredible accuracy.
Okay.
Think about it. You can move your hand up and down, left and right, forward and back.
Right.
That's 3 degrees. But you can also rotate your hand around those 3 axes. That gives you a total of 6 degrees of freedom.
I see. So it's not just tracking the position of my hand, it's also tracking the way my hand is tilted and rotated. That makes sense. But why is that so important?
Because to mimic human movements accurately, you need to capture all those nuances. With RoboPilot, you're not just giving the robot basic commands, you're showing it exactly how you want it to move.
So it's not just teleoperation, it's almost like teaching by demonstration.
You got it. And that opens up some amazing possibilities for things like imitation learning, where the robot can actually learn to perform tasks by watching a human do them.
Now that's where it gets really futuristic. A robot that can learn by watching. Sign me up.
And here's the best part. Because RoboPilot is web-based, you can control the robot and collect data from anywhere with an internet connection.
Wait, so I could potentially train this robot to make my morning coffee from my couch?
Exactly. Think about the possibilities for research and collaboration. Researchers from all over the world could use RoboPilot to control AhaRobot, collect data, and train AI models, all without needing to be physically present in the same lab.
That's mind-blowing. It really does democratize robotics research.
It really does. And they've already been putting RoboPilot through its paces with some pretty impressive results. They've had AhaRobot perform tasks like delivering coffee across multiple floors, navigating hallways and corners, even preparing food.
You're kidding. This $1,000 robot can actually navigate a multi-story building and make me a snack. That's incredible.
It is. They even had it press an elevator button, which requires some serious understanding of the environment and how to interact with it.
Wow. So it's not just about simple pick-and-place tasks. It can actually understand its surroundings and interact with them in a meaningful way.
Exactly. They even compared Robopilot to other teleoperation methods, like leader-follower systems and something called a space mouse.
I've heard of a space mouse. It's kind of like a 3D mouse used for design and engineering, right?
Right. But Robopilot blew those other systems out of the water in terms of speed, ease of use, and success rates on complex tasks.
So not only is it more affordable and accessible, but it's also more efficient and effective. That's a game changer.
Absolutely. And it has massive implications for the future of robotics research. Imagine researchers all over the world collaborating on complex tasks, collecting massive amounts of data, and training AI models remotely, all using this incredibly low-cost and accessible platform.
It's like the Internet of Robotics.
Yeah.
It's connecting people and machines in ways we've never seen before.
Yeah.
Okay, I have to ask, what are some of the limitations of a robot? It can't be all sunshine and roses, right?
Of course, no technology is perfect. A robot is still under development, and it does have some limitations.
Like what? What are some of the challenges they're still working on?
Well, for one, it's a bit on the heavy side. It weighs about 51 kilograms, which can make it challenging to move around, especially in tight spaces.
Okay, yeah, that's not exactly lightweight. It's more like a hefty piece of furniture.
Right. And it also lacks collision sensors, which can be a problem if it's operating in a cluttered environment.
So you have to be careful it doesn't bump into things and break stuff.
Exactly. And because it relies on vision for teleoperation, there can be some lag, especially in dynamic tasks where things are moving quickly.
That makes sense. It's like playing a video game with a slow internet connection. It's hard to keep up with the action.
That's a good analogy. But even with those limitations, the potential here is mind-blowing. They've also been experimenting with imitation learning, having the robot learn by watching humans perform tasks.
Oh, right. You mentioned that earlier. So they're moving beyond just teleoperation and trying to teach the robot to learn and act autonomously.
Exactly. And they've had some success with tabletop manipulation, like picking up objects and placing them in specific locations, but teaching it whole body movement, where it's using its base and arms together, is still a challenge.
I can imagine that's incredibly complex. It's like teaching a baby to walk, but you're dealing with motors and algorithms instead of muscles and neurons.
Right. And one of the issues they've run into is that the encoders on the base, which are used to track its position, have limited resolution.
Resolution, you mean like the pixels in a camera?
Kind of. It's the level of detail the encoders can capture. And when you're trying to teach it fine movements, especially through teleoperation with Robopilot, those small adjustments can create spikes in the data.
So it's like the data is getting corrupted or distorted because the sensors can't keep up with the subtle movements.
That's a good way to put it. And it makes it hard for the learning algorithms to make sense of what's going on.
So they're trying to teach it to dance, but its feeder's too big for the dance floor.
Exactly. So to address this, they've been experimenting with using position control instead of velocity control for teaching base movements.
Position control versus velocity control. Okay, break that down for me. What's the difference?
Think about it like this. With velocity control, you're telling the robot how fast to move. But with position control, you're telling it where to go. And it turns out that position control results in smoother, more predictable movements, which makes for cleaner data that the learning algorithms can actually use.
Ah, I see. So instead of saying, move your foot this fast, they're saying, put your foot here. It's a more direct and precise way of controlling the movement.
You got it. And it seems to be a lot more effective for teaching complex movements, especially when you're dealing with limited sensor resolution.
Okay, so it's all about finding ways to bridge the gap between human intentions and robot capabilities. It's like creating this new language of movement that both humans and machines can understand.
That's a beautiful way to put it. It's an ongoing challenge. But the progress they've made with Robopilot and imitation learning is truly remarkable.
I'm absolutely blown away by what they've achieved with AhaRobot. It's affordable, it's versatile, it's incredibly innovative, and it has the potential to change the way we think about robotics and AI.
I couldn't agree more. It's an incredibly exciting time to be in this field.
Before we move on, let's recap some of the key takeaways from this part of our deep dive into AhaRobot.
Absolutely. I think the biggest takeaway here is that AhaRobot is not just a robot, it's a platform for innovation. Its open source nature and affordability open up countless possibilities for research, development, and even personal use.
Right, it's like a toolbox for the robotics revolution. And Robopilot is the ultimate power tool in that toolbox.
Exactly. It's a game changer for teleoperation and imitation learning. And the fact that it's so affordable and accessible means that anyone with an internet connection can potentially contribute to the advancement of robotics.
I think the other big takeaway is that AhaRobot is proof that you don't need $1 million budget to do cutting-edge robotics research.
Exactly. Innovation can come from anywhere, and our robot is a testament to the power of creativity, ingenuity, and collaboration.
This is starting to feel like the beginning of a robotic renaissance. It's like we're on the cusp of a new era where robots are no longer just tools for industry and research, but companions, helpers, and even extensions of ourselves.
I think you're right, and it's incredibly exciting to think about what the future holds for our robot and embodied AI as a whole.
So where do we go from here? What are the next steps in the evolution of this technology?
Well, the researchers are already working on addressing some of AhaRobot's limitations. They're looking at ways to reduce its weight, add collision sensors, and refine the teleoperation system to minimize lag.
So they're making it more robust, safer, and easier to use.
Exactly. They're also focusing heavily on improving imitation learning algorithms. They want to make it easier for the robot to learn complex, multi-step tasks from human demonstrations.
So it's not just about mimicking movements, but understanding the intent behind those movements. That's a whole other level of sophistication.
Absolutely. They're also exploring ways to incorporate more advanced AI models, allowing the robot to reason about its environment, make decisions, and even anticipate human actions.
So instead of just reacting to commands, it could start to learn and adapt on its own, becoming more autonomous and helpful over time.
That's the goal. And that's why the potential for crowdsourced data collection with RoboPilot is so exciting.
Right. You mentioned earlier that researchers from around the world could use RoboPilot to control a robot and collect data.
Exactly. Imagine a massive data set of human actions and movements, all captured through RoboPilot and used to train incredibly sophisticated AI models.
That could revolutionize the way we interact with robots, making them more intuitive, responsive, and personalized to our individual needs and preferences.
It's a really exciting prospect. And as these AI models improve, we could see robots becoming less like machines and more like partners, collaborating with us to achieve common goals.
It sounds like we're moving towards a future where robots are less like tools and more like extensions of ourselves.
I think you're right. And I, for one, am excited to see where this journey takes us.
Me too. This has been an incredible deep dive into AhaRobot. We've covered a lot of ground, but there's still so much more to explore. Thanks for joining us on the deep dive.